Integral of secant x is another handy integral that we need to know. Here I'm going to show two different methods. Method 1 is a very common way that you can come across in your calculus books. In the first method, we're going to multiply our integral with secant x plus tangent x, and we're going to divide with the same expression. So anything divided by itself is 1, so we're not changing the integrand, we're just reorganizing. So our first step is to multiply secant x by secant x plus tangent x over secant x plus tangent x. Now we're going to distribute this on the numerator. So secant x times secant x from the first term plus secant x times tangent x from the second term, all over secant x plus tangent x. Now secant x times secant x is secant squared of x. Here we're going to apply u substitution. Let u be equal to our denominator secant x plus tangent x. Then du will be derivative of this. Derivative of secant x is secant x tangent x, and derivative of tangent x is secant squared of x, and we have the x here. If you solve for dx, then dx will be equal to du over this whole expression, secant x tangent x plus secant squared of x. If you realize that this denominator is exactly what we have here on the numerator, so we can cancel that out easily. Now let's rewrite everything in terms of u. So what we have on top is secant squared of x plus secant x tangent x, and on the denominator we have secant x plus tangent x that we call u, times, instead of the x we have du over secant x tangent x plus secant squared of x. Now this is identical, so we can cancel out. Now what we have is 1 over u du, which is a very common integral. We know it is ln of u. And if you bring u back, it's going to be ln of secant x plus tangent x plus c. So integral of secant x is ln of secant x plus tangent x. This was method 1. Now we're going to apply method 2, which requires more algebra, but you apply a lot of rules that makes you stronger on computations.